So in today's lesson, we're going to talk about the fundamental theorem of algebra. Fundamental theorem of algebra says the number of degrees in a polynomial tells us that we should have that same number of roots. So the same number of roots. So your highest degree will tell you the number of roots you should have. Okay, so for example, if I have a polynomial that has 2 degrees, how can I draw a polynomial that has 2 degrees that have 2 real roots? Yes, this way, but where does it have to cross? What's that? Yes, correct. So if I have a polynomial of 2 degrees and then I said that there are 2 real roots, then it has to cross the x-axis twice, right? What if I say this second degree polynomial has only 1 real root? Then how would it look like? It has to be this way, a function? Huh? How would it look like on the graph? Not sideways. Sideways are not functions because it will fail the function test, vertical line test. Huh? Yes, basically it would just kind of bounce off, right? That's the only way we can have just 1 real root. What if I tell you that there are 2 imaginary roots? How would it look like? Just not touch the x-axis at all. So somewhere else, not touching the x-axis, right? So no matter what, if it tells you there are 2 degrees, you're going to have 2 roots, whether that is 2 double roots, 2 real roots, or 2 imaginary roots. But you should have 2. Okay, so, all right, vocab. All right, vocab is important. Standard form. Standard form of a polynomial is just like x to the 6th plus x to the 5th plus x to the 4th, blah, 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 like that. You're adding all the terms together. That's called a standard form. This next one you're going to see a lot. So make sure every time you read a question, maybe you want to circle, what kind of answer they're looking for. This one's called linear factorization. That's kind of the stuff we did on the warm-up. But basically, you want linear factors. Linear factors, meaning all the factors are only 1 degree. Okay, all the factors are only 1 degree. There might be a in the front, but all the factors means everything's multiplied together. They're all 1 degree. So this is called linear. Linear means line, means 1 degree. Factorization, so we want factors. All right, so make sure you know the difference between the two. One is standard form. That means you want to multiply everything together. The other one is in factored form, so everything is multiplied together. Good? Okay, let's look at an example. Given the polynomial, blah, 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 find the zeros and write a linear factorization of the function. Oh my gosh, that looks bad. What are you going to do? We got to find all the factors. What are you going to do? P over Q. Wow, that's scary. 69. Oof. Well, this one, since they are, they didn't say not to use the calculator. We're going to use the calculator. We're going to graph it, and what are we looking for? Zeros. We're looking at what crosses the x-axis. Hopefully it's an integer or some kind of recognizable fraction, so we can figure out what the other ones are. Okay, we can do this. What 0 did you see? 3? Okay, let's double check. Sometimes, I don't know if you double checked with your table to see if it's 0. I did not, so I don't know if it's actually 3, so I'm going to double check. Let's make sure that it is 0 before we proceed. Ugh, the numbers are so big. Okay. Mm, 10. Did I do something wrong? You got 0, then I did something wrong. 132, whoops, sorry. Okay, so it is 0, that's good. All right, so now what's the next thing we're gonna do? Yes, synthetic division, divide it out. That way we can figure out the rest. Okay, so synthetic division, divide it out, look at the remaining polynomial, and since the leftover polynomial is going to be second degree, you can use quadratic formula if it's not factorable. Okay, once you get to the synthetic division part, it should give you 0. Okay, from here, x squared minus 7x plus 23, whoops, you need to continue. Because they want you to find the linear factorization, so you need to continue until you do get to linear factors. So either you can factor, it does not look like it's factorable, so you're going to have to use quadratic formula. Okay, so let's look at the zeros before we move on. So the zeros are 3, and then we have 7 plus minus square root of 43i over 2. All right, now we need to write this in linear factorization. So that's going to be a little tricky. So it's always going to be x minus the 0. So the first one is easy, x minus 3. The second one and the third one are going to be pretty tricky. So it's x minus the entire thing. Now there are 2 zeros because of the plus minus. So we're going to have to write each one by itself. 7 plus square root 43i over 2. And then x minus 7 minus square root 43i over 2. Okay, so like that. Now we have linear factorization. Now, this is the last part. This is the tricky part. When you look at your answer on the homework, it's not going to look like this because this is in a very complex way of writing it. So they usually want to write it so that there's no fraction. We want to get to the point where there's no fraction. So the question is, how do you do that? Yes. So you can see that the problem is that there is a 2 here. We don't want this 2 here. So what we can do is multiply everything by 2 in the front. And then when we distribute, that 2 is going to be gone. Yes. Let me double check, make sure it is correct before I tell you that is the correct answer. Okay, sorry, I can't just multiply by 2. Okay, so what you're going to do is you're going to combine this into one fraction. I believe it is correct. Okay, 2x over 2 minus this whole thing, 7 plus square root 43 I over 2. I am trying to make a common denominator. The common denominator is going to be 2. Yes. Okay, same thing with this one. 2x over 2 minus 7 minus square root 43 I over 2. Okay, so the algebra on this one is just a little bit involved. Okay, so now we're going to combine the two fractions together. So it's going to be 2x minus parentheses 7 plus square root 43 I all over 2. Same thing here, 2x minus parentheses 7 minus square root 43 I all over 2. Okay, we have a very complicated stuff going on here. So then both of them have a denominator of 2. So what I'm going to do is I'm going to pull it out of the entire thing. So I am going to take out 1/2 from here and 1/2 from here. Basically, I'm taking out the denominator. So I take out 1/2, I take out another 1/2, becomes 1/4. So 1/4 goes into the very front, and then we just have the numerator for everything. Yes.
Wouldn't you have to take it out
X minus 3. No, I basically, if you look at this is just saying 1/2 times 2x minus, yeah. Okay, so I took out 1/2 out of those two factors. I put the 1/4 in the front, and if you look at your homework answers, they would look like this instead. Okay, so if you wanted to compare to see if your answer and the book is the same, then you have to do this step. Okay, so good algebra practice for next year. Yeah, next year's algebra is complicated. All right, so zeros. Zeros are these ones. Linear factorization is this one. Okay, so if they're asking for the zeros, it means what makes y 0. So when you solve, you have 3 numbers. When they ask for linear factorization, they actually they want you to write in factors multiplied by each other. All right. Let's try it. Find the zeros and write a linear factorization of the function. So the only 2 zeros you can see are -2 and 1/3. So let's try -2 first. 3, so that's -6, 2, -4, 2, -4, -1, 2, 0. Okay, from here we know there is a 1/3, so we can continue. 3, 1, 3, 1, 3, 1, 0. Okay, so we get to the point we get 3x squared plus 3x plus 3 equals 0. You can either do quadratic formula as is now, or I took out 3. So then I could see it a little better and not do a big calculation on it. Okay, so now use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So this is -1 plus or minus 1 minus 4 is -3. So that's going to be square root 3i over 2. All right, now I have 4 zeros. X equals -2, 1/3, minus 1 plus or minus square root 3i over 2. Okay, the hard part. Write this as a linear factorization. Okay, I have x plus 2, x minus 1/3, x minus -1 plus square root 3i over 2, and a x minus -1 minus square root 3i over 2. All right, now please be careful. What happened was at the very beginning, I factor out a 3. So then I have to put the 3 in the front. If you didn't factor out the 3, when you solve for the 0 using quadratic formula, you're going to lose that 3 because quadratic formula only finds the zeros, not the actual factors. So you need to kind of remind yourself, basically, there's a leading coefficient of 3. Make sure you put that 3 in the front at the very end. All right, now it's a matter of trying to simplify this whole thing. So if you recall from the previous example, I need to put a 2 over 2 here so that I can add them together. Eventually, I'm going to take out 1/2 from each of the factors. They will combine into 1/4 that goes into the very, very beginning. So that's going to be 3/4 in the very front. And then I have a x plus 2, x minus 1/3. You could try to change that x minus 1/3 if you want as well, but it's not necessary. Okay, -1 plus square root 3i, and then a 2x minus 1 minus square root 3i. And then, of course, you can continue simplifying as much as you want, but this is pretty good, I think, if you can get to this point. All right, last part, complex conjugate theorem. Huh? Plus, minus? What happened? Oh, okay. So if a polynomial has a complex root, it must come in pairs. So I'm sure you remember this from last year. They have to come in pair. That means if you have a plus bi as a root, then a minus bi must be a root. Only for complex numbers, okay? Only for complex numbers. Sometimes when, the question says x equals 1 and I ask, is there another root? Someone will always say -1. No, only complex numbers. Only the ones with the imaginary. All right, so let's find the polynomial in standard form of the lowest degree that contain these 3 roots. So first, they want a polynomial in standard form. That means they want you to multiply everything out. Not in factor form, in standard form. It has to be in the lowest degree. That means it has these 3 roots and 3 roots only. They don't want more than these roots. Okay, so they have these 3 roots, or they have these 2 roots, 2i and 2. Well, the complex conjugate theorem says if you have a 2i, then you also must have what? -2i. So it has to come in pairs, which is the -2i. So we are going to write them as factors first. So y equals x minus 2i, and I'm going to put the 2 i's together so it's easier to multiply. X plus 2i, and then x minus 2. Going to multiply all that together. X minus 2i times x plus 2i is going to be a minus b times a plus b situation, so take the shortcut. A minus b, a minus b times a plus b is what? A squared minus b squared. So this becomes a squared minus b squared. Okay, a squared minus b squared times x minus 2 at the end. All right, x squared is just x squared. 2i squared. 2i squared becomes what? Okay, everyone is giving me the correct answer, but in like different ways of simplification. Okay, 2i squared is just 4i squared. I squared is -1, so it's -4. And there's a negative in that beginning part, so it's plus 4. Okay, now just FOIL. X cubed minus 2x squared plus 4x minus 8. Okay, there's nothing to combine like terms with. So that's it. Good? Got it? Okay, next one. If the 0 that is given is 2 minus I, what must also be a root? 2 plus I. Okay, this one is the hard one to find. Okay, so remember, you're going to take x and then subtract every 0. Okay, subtract every 0. All right, this is going to be complicated because this is hard to FOIL. I'm going to distribute that negative sign first. Okay, I don't know if you remember a few days ago when during the warm-up I said there was a shortcut, right? So we can see that this part is repeating. We're going to call that A. This part is repeating. We're going to call that B. So this is A plus B times A minus B. So again, we have a A squared minus B squared. The a part is x minus 2. The b part is I. So a squared minus b squared. Okay, so you have to find the standard form of x minus 2 squared in your head. That way it will be fast. So if you recall from last year, square the first term, square the last term, take the product and double. Okay, so x minus 2 squared becomes what? X squared minus 4x, double the middle, and then square the last one, plus 4. All right, I squared is -1, and there's negative in the front, plus 1. So this is x squared minus 4x plus 5.